All right, what's up, y'all? Here we are at the end of chapter 6, this section 10.6, quick and easy. To tell you the truth, this is not going to be on the test or anything, but we do need to go over, basically for other classes, sometimes they bring up other mathematical models other than linear regression, which is all we've done in chapter 10 so far. So we're trying to see if there's a relationship or a correlation between paired data, just like we did with linear correlation in the previous two sections of chapter 10. But the difference is maybe it's not going to be a linear, maybe it's going to be some other type of correlation. So we're going to be using R to determine which is the best. Again, we're going to be using TID4, make things go a lot faster. And the idea is if you look at the R, whatever's closest to 1 or negative 1, that's what you should use. That's the best. Or sometimes you just have R squared, so that gets rid of the negative, and in that case, whatever's closest to 1 is the best. So some things we would look for is that the general shape is like this one, linear, like we've done before. So it's basically making a line when you look at the dots. It could be that it makes a U shape or a parabola. That's also known as quadratic regression. And the calculator will tell you at the top of the screen, when you do quadratic regression, y equals ax squared plus bx plus c, and below that it'll tell you what a, b, and c are. Then it could be, instead of a parabola, it could be a shape like this. Well, this shape is starting off low and it's slowly going up. So at first it goes up sort of fast, a little bit fast, and then it keeps going up but not very rapidly. That is logarithmic correlation. And then it could be that something that starts off very low or very small, grows a little bit, and then grows really fast. That's exponential regression. So here is an example. So we put the x's in list 1, the y's in list 2. Ta-da, that was quick. And then what I would do is go right here to stat plot and set up the scatter plot. And if you take a look at this, there's one plus sign right here, so one data point. Then it goes up, and then it starts to come back down. So that is the parabola shape. So you just go to second calculate, the quadratic regression. And if you weren't sure, you could just go down the line, try linear regression, try quadratic, try cubic, etc., and see whichever gives you the best R value. This one, I'm pretty sure it's quadratic, so I'm going to go to that, quadratic regression. The R squared is almost perfect. Couldn't be closer, 0.999. So it's nearly a perfect parabola. Then you would just put negative 2.071 for the a in front of x squared, and then this for the b in front of x, and then this would be the constant at the end. Ta-da! Maybe sketch a little graph of what we saw right here to show that it's parabolic or parabola, and that's it. We're done with number 1. Okay, on to the next one. So what about this data? So notice this, it goes from here to here, it doubles, and then it doesn't double again, but it does grow, and then it grows a little bit, a little bit, a little bit. So it starts off growing a lot, and then slowly grows. That is like natural logarithmic. So put the data, again, in list 1 and list 2. If you take a look at the graph, it grows rapidly at the beginning, and then it grows, but very slowly over here. So that's logarithmic. So that one is the 9th one in the list. So this stands for natural logarithmic regression. And you'll see that R squared is equal to 1, so it fits perfectly. So you just put the constant a in front, 1.97, the number b, 3.021, multiplied with natural log of x. And one more. Here's one that starts off very small, it grows, and then it starts growing very rapidly. So for things that grow very rapidly like that, that is exponential regression. Here's the data put into the list. Take a look at the scatter plot. Now this one, there were, 5 or 6 points, but I can only see one right here, one right here, one right here, and this is where it starts to grow rapidly. So it must have been very small right here, very small right here, small, and then medium, and then big. So that's exponential regression or exponential growth. So that's the 10th one in the list, exponential regression. And you'll see again, this one fits perfectly. R squared is equal to 1. So 1951 is the constant in front, and the base, 4.933, raise it to x. Then just sketch a little graph of what it looks like, and you're done. Okay, we're on to chapter 11, and nearing the end of the semester.